everybody. Thanks for tuning in to a conversation with Fetch. I'm delighted to have Toby and Humayun joining us today to shed some light on the Fetch project. Thanks for stopping by, guys.
It's our pleasure.
Awesome. Perhaps we can start from the very beginning. So what's the genesis story behind Fetch, how you guys came to be, and what key problems you're looking to solve?
Yeah, actually, it's quite a long story. One of the things that we see a lot in this space is that issue of looking at a piece of technology and building something for the sake of that piece of technology, when obviously really what you should be doing is trying to solve particular problems. And one of the problems that we've been trying to figure out how to solve now for the best part of 10 years is how to create an environment big enough so that all of the component parts of the economy could be represented in it, and that they could be introduced to each other so that they could perform value exchanges most efficiently. Effectively a huge dating agency for value providers, so that we could connect those that have to those that want seamlessly using machine intelligence in order to do that, which is actually a really complicated problem. And the reason why we're trying to do it is to try and strip some of the complexity out of our lives, to sort of roll that red carpet out in front of us and to make life easier to solve all of these problems, things like transportation, energy, and many others, by bringing all of those component parts, the autonomy and the authority to get things done without human intervention. It was actually the advent of decentralized ledger technology that provided us with the key to this puzzle, because it meant that we could get the scalability that we needed in order to be able to support potentially billions of these individual component parts. We needed huge scale. Decentralized ledger means that we can add any number of computers to this network, whether we trust them or not. It also provides us with digital identity, which is really important for both human representatives, but also all of these machines. Yeah. And it gives us a value exchange and the computing power we need in order to crunch the numbers to introduce the agents together so that they can get things done.
Right. Cool. So it sounds like the next step in the digital revolution, ultimately, making our lives easier through accessing this previously untapped information that's out there. Could you give us an example of a use case?
Yeah, do you want to have a shot?
Right, so I think before we kind of jump into an example, I think what needs to be understood is there is a multiple stakeholders, and what is quite interesting is that all these stakeholders have to come together to deliver value. And one use case where the issue is that what does actually a network like Fetch would provide in the real world case. And if you look at a lot of the businesses at the moment which are intermediary based, and without naming too many corporates, if there is a taxi company which sits in the middle, which makes connections between the consumer and the supplier being the taxi driver and consumer being us, the central entity which sits in the middle provides you three main things. One, it provides you the trust. Second, it provides you, so the trust means that you can trust that the entities you're doing business with are trustworthy. What it provides you is search and discovery. So search and discovery means, you're looking for a taxi, you need to get connected to a taxi. How do you do that? So there has to be a search and discovery mechanism. And then the last bit is that once you have connected with each other, how do you conclude the business? How can you complete the transaction? So what Fetch does is, rather than just doing it just for the payment method, it does all three functions. What it does is it provides developers to enable them to deploy these solutions, which would have been quite costly. So, such a intermediary taxi company would cost you 10 to 15% in the middle between the transaction. In our case, that would not be the case, and it'll be just the transaction costs, so which is considerably lower than an intermediary. But what it does provide is, as a collective, the people who deploy such a solution would provide that search and discovery mechanism, the transactional part of the mechanism, and the trust mechanism. And we've just completed a trial with an identity provider, so that we can actually enable self-sovereign identities to different entities, different stakeholders. What that enables is brings that trust element.
Nice. I think one of my questions was going to be about the autonomous agents, the open economic framework, and the Fetch smart ledger and how that works together. Is that what you've just described essentially?
Well, yes, from a very top level. Now Toby can describe it a bit more technically.
I mean, one way of looking at it is it's sort of like a new economic internet. That new layer that allows all of these digital entities, the things that we call autonomous economic agents, to get useful work done. The open economic framework is a high level on top of the underlying ledger that provides agents, well, for want of a better way of putting it, with their senses, their ability to see, to hear, to touch.
Search and discovery.
Yeah, it's the way that they get connected to the world, that they advertise what they have and that they find what they need. And as they do that, the underlying network is learning what's going on in order to be able to better introduce the value providers to those that want that value. Now that's really exciting, and because it happens on many, many layers. If you're after a vehicle, or you're after a meal, or you're after a restaurant, the chances are you're after it near where you are. The chances are also that there's a number of restrictions and a number of other things that are important to it. It may well be that you're after combining a bunch of things. Not only do you want to book the table, but you need to get there. So you're only going to book the whole lot if you could achieve all those things simultaneously. And it's that kind of thing that we provide with the underlying Fetch system. That ability to be able to, for machines, for digital entities, independently of human intervention, to be able to figure this stuff out. And this is what Humayun was talking about with the trust and the digital identity. The ability to be able to prove that your restaurant has been highly rated by the local regulatory authority, or that you have a certain qualification, or that you are at least a certain age. And to be able to prove those things independently of any centralized entity. And that's really important. Underpinning all of this is the bit we call the smart ledger. Now, we call it a smart ledger for a reason. We've had to build something that is unique and different because we've got a different set of problems to solve. When you're trying to connect potentially billions of these autonomous economic agents to a network and allow them to find and transact with each other, you've got a whole different world of problems to solve. You need a certain performance level, for example, of transactions. You need the transaction fees to be extremely low. Some of these transactions are going to be teeny and tiny and very, very, very small. And you can't have the cost of transaction exceeding the transaction's value. Otherwise, it's game over. But also, we need to be able to perform a different level of on-ledger computing. And that means to be able to solve machine learning and AI problems actually on the ledger itself. And that's a whole different set of problems as well. Incidentally, that ability to be able to do machine learning problems and other aspects of AI on the ledger itself is something that we call synergetic computing. It's really interesting because it allows decentralized large-scale computing problems to be solved. So one problem, for example, that many people will be familiar with is traveling salesman problem. How do you optimize a route so that you go through all the different places you need to go to, but without wasting your time? It's actually quite a complicated problem. It's even more complicated if you make it multi-dimensional. So you're not only, for example, going through all these things to sell something, but you're going to be delivering something, you're going to be doing something else, picking up a meal, doing this, doing that, all over the world with billions of people involved. The idea that you can solve those kinds of problems in a scalable way is a really interesting concept. And that's an enabler for this. And certainly an enabler for the kind of thing I was talking about, where you can connect somebody who wants a car to somebody who has one without that intermediary in the middle.
Yeah, sounds very interesting. So talking about the transaction costs earlier, what made you guys choose Ethereum as a blockchain to launch with?
Well, we chose Ethereum as a blockchain to launch the token with because we wanted the token out there in order to be able to enable people to develop on the test network. Of course, what we're ending up with at the end of this year is a native main network, which has our underlying smart ledger and everything else. Now, Ethereum, of course, supports the functionality that you need in order to be able to do things that you need to do so that we can verify people have the ERC20 tokens in order to be able to work on the test network, for example. So that was by far the best choice for something like that. Also, of course, it's a great example of, and when you see some of the smart contracts and some of the computing that people are doing on the Ethereum network and have been able to do on the Ethereum network, it's an inspiration for the kind of things that we might be able to do in the future.
Yeah, for sure. So I guess we can talk now about the FET token and what role that serves in the ecosystem, and perhaps how the utility of that and the demand for that grows?
Well, there is several ways the demand of that. Well, let's talk about what it's actually going to be used for. So it's fuel for the agents to run. It's a method of rewarding the delivery of the search and discovery mechanism. It's also a value exchange. So if agents exchange things with each other, then that's how they connect. We have a little bit of a different approach in terms of data and algorithms and machine learning and AI. We don't believe that data should be solved. We don't believe that the algorithm should be solved. We believe that predictions should be solved. And the reason why we say that is because if you're going to make a decision, what is the purpose of data and algorithm is to give you a prediction to make that decision. And what we're building is a fabric where you can actually deliver these predictions. So the agents who need the predictions can have those predictions on demand. And it's a mechanism for value exchange in that prediction economy. And when I say prediction, these predictions are not like sport betting predictions. These are not predictions like some other projects are doing in the sense that, I mean, who's going to win what. It's predictions whereby a action is broken down into smaller actions, and to complete those actions, you have to make decisions. And to make the decision, you need a prediction. So just to give you an example, if you're going to walk out, either to take an umbrella or not depends on what your prediction of the weather is. So in the next hour, is it going to rain? If it is, then you're going to take an umbrella, otherwise you won't. So that prediction has value, and to exchange and buy or sell that prediction, you need a mechanism. And these predictions could be half a cent, 1 cent, 10 cent, dollar, maybe more, depending on what the value of the whole transaction is. So that's also a mechanism of exchange for that. And then on top of that, it's a staking mechanism because we're a proof of stake combination with useful proof of work.
Actually, useful proof of work is worth touching on. So we've got a combination of all of these things, that we get the appearance of having central coordinators without having central coordinators, which is really cool because in a the whole point of decentralization is that it's decentralized. And when you start having any aspect of a network like that is centralized in any way or fashion, then you sort of blow that out of the water, which is really not a good idea. So we've got a unique combination of proof of stake, a directed acyclic graph, a DAG, that acts in between to provide that appearance or that ability of coordination, and also useful proof of work, which we use for optimizing the network's performance itself. And that's really cool because it owes a lot to modern CPUs with out-of-order instruction execution, where you can pull something from the future to the present, rated in parallel if they don't collide with each other. But we've got the same mechanism with transactions on this multi-lane. Effectively, we double the performance of blockchain by having 2 of them, and then 4 of them, and then 8 of them. But actually, it's coordinating things across those lanes that becomes very interesting. And that's what we do with useful proof of work, optimizing all of the parts like a giant Tetris set, in order to ensure the maximum throughput of transactions through the system. It's very interesting to note things like predictions, because as Humayun says, it's not what has happened that's interesting, it's what will happen. And all aspects of economic activity are entirely dependent on the ability to be able to know with some certainty what's going to happen. And encouraging that prediction economy, where people can buy up low value information of, say, people passing by a road junction, and then combining it with machine learning and the knowledge of what's going on to be able to produce these predictions, so that you can effectively say, mine said, do I need an umbrella? But also, if I leave work now, how long is it going to take to get home? Or better still, when should I leave work in order to get home when I want to in the most efficient way? That actually these agents may be building these predictions, selling them on. Other agents may be buying other people's predictions and combining them to do even something else. So it's more layered. By the time you get a solution to your problem delivered to you, many thousands of agents may have traded many thousands of predictions and other pieces of information in order to be able to do that. So it allows those complex problems to be solved independently of you, and those solutions just to come straight at you without you having to poke around in endless different apps to be able to deliver that.
Sounds really good. I think you answered a lot of my questions in that. Perhaps one would be, is there space for a malicious actor to come in and start trading or putting false information about anything in the economic environment?
Well, there's always a space in the world for malicious actors, isn't that the case?
True.
But in the end, one of the things that we get with decentralized ledger technology is this whole self-service trust aspect of things. And Humayun touched on it earlier, with connecting to self-sovereign identity and having verifiable credentials, where you can actually prove that certain things are true. You can prove that you have a certain qualification. You can prove that you're entitled to deliver a certain piece of information. And all of these proofs combined means that there's a high level of trust between agents that are performing these kinds of transactions. And there's always going to be malicious actors on a system like that are coming in there to try and get something that they're not entitled to. But in the end, when you've got a world that's learning who connects to who and under what kind of circumstances, then effectively the bad actors in the environment almost become invisible to everybody else. Because if you don't have those trusted credentials and you don't have the reputation that is built up by performing well on a network like that, then depending on your personal risk profile, you may find that all of those bad agents simply disappear from view. So you're heavily incentivized to behave well in a system like this, or to behave creatively, even if it is taking other people's information and repackaging it in some way. Because eventually, if you are providing some other kind of additional value on top of that, then you'll start being visible to other people.
Yeah.
And just a bit more detail in the sense, we have a consensus mechanism which, if you're looking at the block production, then the consensus mechanism takes care of that itself, because it's a proof of stake and with use of proof of work. So it's a combination of that, and the block producer is, even although there is a proof of stake, it's still chosen at random. So that takes care of that side of the actual transaction layer. In terms of the actual agents and the trust rating of those agents, there's a built-in trust rating mechanism on the ledger which enables you to analyze the transactions, and it actually, as Toby said, it brings out all the bad actors. It kind of chucks them out in the sense that you'll never find them.
To a certain extent, it's almost, when you look at any given transaction, it's how normal is this? And this is how credit card companies spot that the 10,000 tons of tires you're buying from Brazil is not normal for you. It might be normal for you. You could be a tire tradesman, but you probably aren't if you're just popping in at an airport somewhere on the way to somewhere else. So that ability to know how normal a transaction is, given the circumstances, is an important part of trust. And that's one of the things that this network builds over time. And that information is available to everybody. And as we're fond of saying, there's lots of little bits of knowledge that when they're joined together form this kind of collective intelligence that's really important to all of the users. And that's what decentralization gives us. It means that instead of that knowledge being locked up in individual centralized silos, it's available to everybody on the network to be able to use, which also enables all sorts of other interesting new business models, as what might be previously these narrow verticals can be taken apart and reassembled and combined in different ways to produce different kinds of applications. And that's another area that we think is really interesting.
Yeah, it sounds amazing. Perhaps we can talk briefly about the roadmap, and are there any exciting partnerships or iterations coming out soon?
Everything's exciting at the moment, and there's a lot going on. Incidentally, I would just say that we have some great papers that are available on our website talking about minimum agency consensus and our scalable ledger, and a whole bunch of other things relating to the synergetic computing and our smart contract system, which are really fantastic reads that really talk about some of this technology in more detail.
I'll put links in the description.
Very much. And also the software, the stuff, that includes the VM that runs the synergetic computing system and the smart contract system. That stuff is available now on GitHub. We have a test network. Anybody who has got an ERC20 token can qualify to get access to that test network and can build agents, contracts, and other things today. I mean, that's possible now. We're aiming at a mainnet release at the back end of this year. And we're continuing to update everything as the year goes on, adding more stuff relating to the open economic framework. We're doing a lot of stuff on our community website at community.fetch.ai that talks about how you can build things, and we're doing new tutorials pretty much weekly at the moment that look at the different code and walk you through creating agents in, say, Python or C++. So we're giving people lots of options, lots of things to build with and to take apart and to put together in different ways. So from a technical perspective, that's the kind of stuff that's going on. We're also founding members of Blockchain for Europe, along with Cardano and Ripple and some others, and we're going out there and talking to the regulators, the legislators, and influencing policy, and also getting involved in all of those things, which I think is also important for this space as a whole.
Definitely, yeah.
Yeah, and always
commercially,
yeah.
I think just we're working with some telcos which are showing quite a lot of interest because there is a completely new business model here. What you have is telcos could, because they're controlling the data transfer, they could actually deploy a new style of business model. So it's very much a SaaS business model, but they don't need to actually deploy it. They can just support it. So there is a lot of interest from the telcos. There is a lot of interest from asset providers. So I'm not going to name anything because there's some confidentiality, and there's some PR coming over the next couple of weeks. But I can lead you into what kind of companies you can expect to see something with. So what we're doing is we're kind of taking away the intermediaries. So all the asset generators, asset providers, or asset manufacturers are the companies which are interested in such a system because it takes away a huge amount of cost from the middle. So what it delivers for example, hotel owners or hotel rooms could find their customers quite a lot easier going through the intermediary booking services. So it's a lot of interest coming from that side. If you look at the automotive manufacturers, there's a lot of interest coming from there because the model of automotive ownership is changing and it's becoming more subscription based. And when you have a subscription based model, what you're looking for is how quickly can you find your consumer, and how flexible can you make such a model. And it's absolutely the right platform or protocol, which is what Fetch is building. It enables you, without deploying huge amounts of software building costs or integration costs, it can actually connect the two together. So commercially expect quite a bit of movement coming from there. One thing which I would really like to point out is over the next months, we will be launching quite extensive developer programs. And we're launching quite a lot of competitions for development rather than just trading competitions. So the concept is, because we're building our new smart contract language, we're building a smart contract platform where you can actually use machine learning inherently. We're looking for people to participate in this ecosystem by coming in, developing, and actually we will be creating that ecosystem fund, which will enable them to not only develop some creative ideas and deploy them, we can also provide them financial backing.
Yep, come and create. There's all sorts of new things possible. So yeah.
Awesome. Sounds great. I think one last question before I let you guys go. Could you speak about the team behind Fetch? How big are you guys, and sort of what your backgrounds are?
Yeah, well, if you guys don't know, I'm Humayun, CEO, Fetch, and my background is in commodity trading and technology. So we've been building algorithms. I was one of the first investors in DeepMind, worked for the commercial side of things there. And so my focus for the last few years has been mainly on monetizing the machine learning and AI space. So that's my focus. I'll let Toby explain.
Yeah, so I'm the CTO and co-founder, and I originally come from a computer games background, was involved in a series of computer games in the late 90s called Creatures, which was all about modeling metaphors from biology and building a real organism that could learn by itself without human intervention. I love that, the fact that we've got such complexity, some richness, without having to program any of it specifically. applied that also to the creation of vast digital worlds, massively multiplayer online environments, and spent a few years right at the very beginning with DeepMind looking at how some of these biological influences could be applied in their journey to the things that they were doing. And then got involved in Fetch because it's a wonderful convergence of absolutely fascinating technologies. And we're really lucky here because we have an incredible team. There's around 40 of us at the moment, I think.
In Cambridge, we have 40.
Yeah.
We have a team in Austria of 6 people. We're looking to grow in Berlin, a couple of people. We just set up an office in the US, and we're recruiting there as well, just around the MIT area. We're also got an Indian team of developers, around 6 or 7 people. So we kind of, and we're looking to kind of employ more.
Yeah, great.
Vision, and we need good
we have
people
advisors
to do it.
from various universities, which you'll be able to see on our website.
Perfect. Okay, thanks for stopping by, guys. I'll put all the relevant links in the description, including to these available jobs, if there's a jobs board on your site. And yeah, thanks.
Wonderful, thank you.
Cheers. Take care.